All right, so this is part 2, 5.3b, solving systems of equations by elimination. That means you're going to want to get rid of a variable or something like that. So let's just kind of take a look here at this system right here, and let's call this a review. We notice the x's. We could cancel the x's out by subtracting all of these things in the bottom equation from all of these things in the top equation, all these terms. We could subtract, but we are going to stay away from subtracting because there's a lot of mistakes that are going to come in, a lot of negative signs. It's going to further complicate things, so we're always going to add equations. But I do want you to know that I don't want you to lie to you. You can subtract the equations, but I will never do it that way. So if we were adding these equations, if we wanted to cancel out the x's, think about what you have to multiply one of the equations by. So if you wanted to cancel out the x's here, what would you need? Well, you'd need a negative 2x. So if you're going to get a negative 2x, you're going to have to multiply by negative 1. And everything's going to be multiplied by negative 1. Think of this as a distributive property. You'd have negative 2x plus 10, that's going to be minus 10y. So you have negative 2x minus 10y equals negative 12. And the top equation would stay the way it is. I'll write it in blue. 2x minus 5y equals negative 3. Okay, I've got it. And then you could simply draw a line and add together down these columns, this column, and this column, and get a new equation. And you're going to cancel out the x's, and it's going to be a good thing. I want to just remind you that this isn't the only way to do it. You could cancel out the y's too. So think for a minute, okay, about what you would multiply this bottom, or actually let's think about what we'd multiply this top equation by if we wanted to get the y's to cancel out. That's a number you're going to have to come up with. It's not a number that shows up on the problem necessarily. It's a number you got to think of. So think of a number. So hopefully you thought of 2. So I'm going to put times 2 here. I'm going to multiply this whole equation by 2. So I'm basically going to take the 2, I'm going to distribute it like this. And I'm going to have the following. I'm going to have 4x minus 10y equals negative 6. Now why was that smart? Well, if this equation stays the same, we have 2x plus 10y equals 12. What's great about this? Think about what's good about this. Well, hopefully you're realizing that when you add the negative 10y and the positive 10y, they cancel out. They eliminate. So we have 6x, because we add 4x to 2x, equals 6. And when we divide by both sides by 6, basic algebra skills coming into play here, we have x equals 1. And we're not quite done. Here's a question that I get from a lot of students. Well, what equation do I plug this into? I could plug it in here, I could plug it in here, or I could plug it in here. The answer is you could really plug it into any of those equations, but my suggestion is to plug it into one of the 2 original equations. When I say it, I mean the x value to get the y value. So take x equals 1 and plug it into one of the original equations. Me, personally, I'm going to use this bottom equation. It has a lot of positive numbers. It seems pretty straightforward. It's right here. So 2 times 1 is 2. That's this. And then the 10y stays the way it is, and the 12 stays the way it is. Then we're solving that, which ends up giving us 10y equals 10 when we subtract 2 from both sides. And finally, y equals 1, and our answer is 1, 1. So that is what we should already be able to do, ideally. So I'm going to give you I'm going to give you an example. You probably have it on your sheet now. I want you to try this. So pause the video, give this a shot, do your best. This is part of your homework, so you've got to have this example worked out when you come into class. And yeah, give it a go. Just pause the video. Okay, so if you haven't finished, pause the video. I'm going to tell the answer now. I'm not going to show the work. You're going to have the work to get the full credit. But the answer, if you tried the problem, was -1, -3. And you should be able to check that by plugging those numbers in and seeing if you get something that equals out to 1 or to 23 in those equations. So good. We will be moving on. We're just going to kind of talk about what elimination is all about. So let's go to the next page. Okay. All right, so a recap of solving by elimination. We know how to solve an equation just for x. That's a skill that we have from basic algebra. So don't forget that when you think about this, you're using basic algebra just solving an equation for just x, right? That's a skill that you're having. We can also solve for any variable. Doesn't matter, n, z, y, t. The letter doesn't matter as long as there is only one variable. That's what you want to fill in, one variable. That's what makes it key. If you have one variable, you can solve. Problem is we don't have one variable when we start. So the idea is to create a new equation that has only one variable. That could be just an x or just a y or really anything. But we don't want to have an equation with two variables in it. We can solve a one variable, we can't solve a two variable. So our goal is to take what we don't know and change it into something that we do know. Make it more straightforward. Once we have that new equation with one variable, we can solve it. And the last step would be to find the other variable by plugging back in. That's kind of substitution in a sense. So the blanks are just one variable, one variable, one variable. The point I'm trying to emphasize here is that we want an equation with one variable, and I'm not going to give you one with one variable, right? But you can make it into one with one variable. So here's kind of an interesting thing. If I want to emphasize this. If we're adding these equations together, right? Well, now we're adding -4 to the -8, right? And that all makes sense, adding -4 to -8. Now here, what are we adding? We're adding -6x plus 2y, but the thing is that -4 is the same, sorry about that, not the greatest writing. -4 is the exact same thing as -6x plus 2y. So I'm kind of adding -4 here as well, if you think about it. Just in a different form. So I like to use the analogy of like ice and water. They're kind of the same thing, but they're in different forms. So that's what's happening. You're adding the same thing to both sides. That's your basic algebra. I don't want you to think something crazy is going on here. It all builds off of what we have always understood. Okay? Okay, continuing on. Oops. Okay. All right. Oh, kind of a little sneak preview there. Okay, so solving with multiplication. So we look at this example and we kind of think about, okay, well, what are we going to do? Like, what are we going to do to get these equations to eliminate? We don't have numbers that match up. This adds to 7. This adds to -4. Not good. We want them to be same numbers, different signs. So step 1 is to find what is easier to cancel out, the x's or the y's. So look at your x's, look at your y's. What could you multiply the x's by on the top or the bottom to get the same number? Or what could you multiply the y by? Well, if you double the 3y, you get 6y. If you double the 4y, you get 8y. It doesn't. If you take half of it, you get 2y. It doesn't really seem to work with the y's as well. I mean, we can make it work, but we're not at that point yet. But with the x's, if you just take the 2 and you triple it, you're going to have 6, right? So we're going to multiply that by 3. So I'm going to put times 3, and I'm going to arrow it, and I'm going to make the new equation. So here's the deal. We want a -6 and a +6. We already have a -6, and now we have a +6. Okay? There's a lot of mistakes with signs here. And don't let that make you feel like you're not good at this. I mean, if you're making mistakes with signs, that's a totally separate issue. I want to make sure you understand the concept. Of course, you make mistakes with sign, it's going to cost you a couple of points here or there. But the big idea is to understand what is really happening. To find this number is really the big deal. To understand that you're distributing here is the big idea. So now we found a number that makes the x's eliminate when we add them. +6 plus -6 is 0. So we have 0x, nothing really. So we have 13y equals 13. When we divide both sides, we get y equals 1. So we have y equals 1 for an answer. We want to know what is x. Okay, so I have skipped some stuff, and I apologize for that. So I'm going to have to show you what I've done here. So let's go through that a little bit. So I am going to try to color code for you a little bit. Do my best. All right. So what I've said here is I said find what's easier to cancel out, x's or y's, and I said multiply everything, right? And that step 2 is kind of happening in red. So multiply everything in the equation by the number that will get you the right amount of x's and y's. So the number is 3 in this case. We already went through that. Okay. Now you notice here you could cancel the x's, right? Oh, you could cancel the x's, but you need positive 6 and negative 6. The only way to get that is multiplying everything in the top equation by 3. So there's kind of a pretty big hint there telling you what number to use. Okay, moving on. Step 3 is to add the new equations together. So that is kind of what's happening in blue here. You notice we're adding the equations together. These are going away. So that's step 3, okay? So notice that we're trying to color code here. Add the new equation to the equation you didn't use yet. The equation you didn't use yet is the thing in green that I brought down. Okay? And you're going to add those together. Now you're going to have a pretty simple equation, which is that blue 13y equals 13, and you're just going to solve that, which gives you y equal 1. And once you have y equals 1, I'm hoping that it's kind of like pretty quick and easy for you to see that you need to take either equation, top or bottom, I'm going to use the bottom, and put y equals 1 into it. So 3 times 1 is 3. So this is the equation we have. We have to solve it. And we're getting easy numbers here a lot of times. So 1 comma 1 seems to be our solution again, okay? All right, excellent. I think that might be it. Okay, so there's one more thing. You are to pause and copy down these problems, okay? So take a look here. Pause the video and copy these down. All right, look at this. We're going to try to cancel that by elimination. This shouldn't be too bad. I'm going to put an E here for like it's one of the easier ones. All right. This one doesn't line up great, but you can put those equals and stack them a little bit better. This one's probably also another easier one. I would say it's pretty easy. You could call it medium level if you'd like. That's not too bad for what we've been talking about. So there's 1 and 2. Maybe I should squeeze this in so you can see all of them. Just bear with me here. Okay, so that messes up my easier. This is an easier equation. This is an easy / medium one. And then this one, how is this one? This one may be a little harder, but that's the last one you have to do. So you have to do 3 systems along with having the notes and the one example earlier today. Okay, make sure you get that done on lined paper, those 3 problems, and you can staple it to your notes or keep it unattached, and that will be checked tomorrow. All right, I'll talk to you soon.